A lot of these forests were growing in wet, swampy environments, and when that plant material is then preserved in those environments, you're sequestering carbon in those environments. So if you're taking out carbon from the atmosphere, you're changing the ratio between oxygen and carbon in the atmosphere.
Researchers suspected that higher oxygen levels during the Carboniferous period were key to insect growth, but they didn't understand the connection. The secret to this mystery is under investigation just outside of Chicago, Illinois, at the Argonne National Laboratory, one of the U.S. Department of Energy's largest research centers. Scientists here suspect that the key to size has to do with how insects supply their bodies with oxygen and are looking for answers about insect respiration in this tiny beetle's body.
The first thing that I do is to take the beetle and knock him out. I simply put him to sleep by giving him nitrogen gas. This is just temporary. It doesn't hurt the animal at all.
Once the beetle has been properly subdued, he's ready for his close-up.
What I'm doing here is placing the beetle on a stand that we can control from the outside, so we can move it up and down and side to side and position where we want it in the X-ray beam.
Searching station C. Exit immediately.
This tiny bug sits at the imaging end of one of the world's most massive X-ray machines.
This is the advanced photon source. It is what we call a third-generation synchrotron. This function is to produce very powerful X-rays.
The synchrotron generates X-rays 1 billion times stronger than a hospital X-ray machine by accelerating electrons around a 1.1 kilometer track at close to the speed of light and harnessing the X-rays they emit. Teams of researchers work at stations around the track,